Yeah, I'll react to that, sure.
In January,
Guys, spiders, I'm getting better with spiders. I used to be a lot more afraid of spiders than I am now. Not a big deal anymore. I never was really afraid of snakes. The only thing that really makes me squirm now, sometimes like a huge flying like cicada or something, but is a centipede. If I see like a house centipede, and I don't feel, and it's the one animal I don't really feel bad killing because the gross out factor is too much. If I see one in my room, I can't just be like, because I know later it might freak me out. And so the fact that there were giant ones is terrifying. So let's find out. Nice castle. England, great beach, amazing grass.
2018, a group of geologists were on a vacation, taking a road trip across the UK. One evening, while strolling along Howick Beach in northern England, one of them spotted something strange. A big sandstone boulder had fallen from a nearby cliff and split in two, revealing the fossilized body segments of a giant arthropod, some kind of enormous ancient millipede. Once it was pieced together, it became clear that this accidental discovery was something really special. Even though the fossil was far from complete, its size made it the single largest arthropod fossil ever found. This huge millipede may have been more than 2.6 meters long, 55 centimeters wide, and 50 kilograms in weight, which broke yet another record, making it the largest.
Okay. Like, millipedes? Like, millipedes do not freak me out at all. I even see like lemurs getting high on them. Lemurs, millipedes. See right here?
As an insecticide.
Like that's a millipede, and that's a lemur getting. So right there, those don't freak me out really, and the fact that it doesn't have like all the legs, like I gotta show you what I'm talking about. I don't even want to look it up. House centipede. No.
50 kilograms in weight, which broke yet another record, making it the largest known invertebrate to ever live on land. It dates to the Carboniferous period, a time pretty renowned for its huge bugs, which we've talked about before in our episode, The Age of Giant Insects. And like we said in that episode, one major hypothesis about why bugs could get so huge during this period was that oxygen levels were much higher then. But there's just one problem.
I'm so jittery now. I can't put my feet on the ground. All right, come on. Doesn't mean there's a house. There could be. I mean, there could be. Like, there could be one of those in my room right now. Think about that.
This new giant fossil millipede dates to tens of millions of years before the spike in oxygen. In fact, at the time this alligator-sized millipede lived, oxygen levels weren't much higher than they are today. So how did this millipede get so big? The fossil found on Howick Beach came from an ancient millipede called Arthropleura, which was first described in 1854. They've left dozens of fossils behind across Europe and North America.
Hey, right where I am. That dot is like right where I am.
Close to the equator during the Carboniferous, so it's thought that they thrived in warm tropical environments. And those fossils have been a mixture of both trace fossils, like trackways of them scuttling across the ground, and body fossils, like fragments of legs and back segments. But well-articulated, even partially complete body fossils of giant Arthropleura have been much harder to come by. In fact, the Howick specimen is only the third one ever found, and it's from the biggest individual by far. It also might actually represent a recently molted exoskeleton rather than the animal itself, which means that this thing could have been getting even bigger at the time. 2.6 meters of millipede was apparently still not enough millipede. The more to admire, I guess. Aside from its incredible size, what was also...
So a fossil is simply the the rock took the shape of what it encased millions of years ago, and so it's not like if you cut open the fossil you're gonna be able to find anything like cool in the rock, right? Like it's digestive, or like right, like it's simply rock that was just like made into the mold of a dead thing, and that's what it is. Like, right? Like, that's all a fossil is. It's just a rock. It's not as if it actually has any genetic material or anything of the animal, right?
What's so interesting about this fossil was its age. See, it wasn't just the most extreme example of gigantism in Arthropleura, it was also the oldest partially complete example. It dates to 326 million years ago, much earlier in the Carboniferous than previous body fossils of giant Arthropleura. Now, in the later part of the Carboniferous, the planet's atmospheric oxygen levels surged, eventually peaking at around 30 to 35%. And this was thought to have been the main driver behind the rise of the notoriously big arthropods of this period. Because in arthropods, oxygen is diffused to tissues and cells through a network of hollow tubes. So the idea was that higher oxygen levels in the Carboniferous allowed this respiratory system to support much bigger body sizes than was possible during times of lower oxygen. But 326 million years ago, when this Arthropleura lived, the rise in oxygen hadn't really begun yet. Oxygen levels were only 23% back then, not a whole lot more than the 21% they are right now. So if oxygen wasn't the key driver behind the evolution of such a ridiculously large arthropod, what was? Well, maybe instead of the atmosphere, the big factor literally was simply being at the right ecological place at the right evolutionary time. This giant Arthropleura would have predated any large terrestrial vertebrates capable of rivaling it, meaning it had few, if any, competitors or predators. Because about 326 million years ago, the vertebrate invasion—
Why do we say that with such certainty? Like, this is what I don't understand. Like, we're supposed to be very scientific.
Right evolutionary time. This giant Arthropleura would have—
How do you know that we just haven't found a fossil of a large animal or arthropod, whatever, back then? Why are they like so certain? And like people say, like the blue whale is the largest animal to ever live on planet Earth. Not the largest animal that we know of. It's the largest animal that's ever lived on Earth. Period. It sounds so unscientific to me. Like, why can't we just say that we know of? It didn't have any predators that we know of. The whale is the largest animal that we know of. You know, is that just me? Like, should that not bother me as much as it is?
Predated any large terrestrial vertebrates capable of rivaling it, meaning it had few, if any, competitors or predators. Because about 326 million years ago, the vertebrate invasion of land was still in its early stages. Amphibians were around at this time.
Okay, that's fine, but it's still, like, don't you think it's not enough? Like, before you found the centipede, like, you would have said, and there were no large animal. You get my point. I'm beating a dead horse.
Some of their time out of the water. Amphibians were around at this time, spending at least some of their time out of the water, but tetrapods hadn't yet established a permanent presence on dry land. Okay. This giant Arthropleura lived in an environment without any reptiles, birds, or mammals. The vertebrates that would eventually fill the ecological niches open to medium and large terrestrial animals. Arthropleura and other arthropods had simply beaten us vertebrates by colonizing the land much earlier than we did. It's free real estate. And they got to reap the rewards of having the terrestrial environment all to themselves. A chance to experiment with gigantism without any major challengers to keep them in check. Now, it's still entirely possible that later oxygen spikes also helped some arthropod groups get really big, especially in the late Carboniferous and early Permian period when it reached its peak at 35%. But at least in the case of Arthropleura, the biggest of the big bugs, oxygen levels weren't the key to evolving huge proportions. Food availability, though, that definitely would have been a major constraint on their size. After all, to support such a large body, they would have needed to consume a lot of high nutrient food. Now, we don't know much about their eating habits because we haven't found any fossils of their mouth parts, but it's likely that they were primarily herbivorous like modern millipedes. And here again, the absence of any serious competition,
much less scary now,
from herbivorous vertebrates would have been pretty ideal. They would have had their pick of nutrient-rich seeds and other plant material that littered the coal swamps and open woodlands of the Carboniferous. But their size might have also allowed them to be pretty capable predators too. So it's possible they supplemented their plant-based diet with animal prey, including other smaller invertebrates and maybe even small amphibious vertebrates, our ancestors at the time. But the conditions that had allowed the giant millipedes to thrive wouldn't last, and neither would they. Both their trace and body fossils vanished from the record around 290 million years ago in the early Permian period. Fossils vanished from the last, and neither would they. Both their trace and body fossils vanished from the record around 290 million years ago in the early Permian period. And their extinction was probably driven by two major changes ago.
You see, like, that sounds like that's sorry, Shrek is on. Great movie, but loud. Like, yeah, like that makes sense. Like, if like you find some before and nobody ever finds one after, then yeah, it's. I'm trying to compare my reasoning to the.
In the early Permian period, and their extinction was probably driven by two major changes. For one, this was around the time that the supercontinent of Pangaea formed, which led to drier conditions around the equator. Arthropleura seems to have only lived in those latitudes and may not have been able to adjust to the increasing aridity. And at the same time, they finally began to face serious ecological competition from vertebrates due to the rise of reptiles in the Permian. From this point on, vertebrates began to take center stage on land, becoming larger, more diverse, and better adapted to terrestrial niches. So this double hit of a changing environment and the appearance of strange new reptilian rivals may have just been too much for Arthropleura. And the opportunity for a millipede to reach epic proportions would never arise again.
That we know of. I was gonna ask a big question. Right. You know how like you always hear like this, like how many animals go extinct every year or how many species, and it's some number, and I don't know like the average would be over time, but you never hear like, you always hear like a newly discovered species, but you don't know if that species had been there and we just hadn't seen it, or if this species literally is new. Like it's new. Like it is different from what it used to be. So like when you can say, all right, this is when it's extinct, but when does a species become like onto the scene? Like what, like how often does that happen? You know?
A milli thanks to this month's eontologists. Annie and Eric Higgins, Chase Archambault.
Really cool video. Preemptive like. PBS Eons is awesome. That could be cool. Really cool video, guys. Hope you're doing well. If not, chin up. You'll be good soon. Don't worry. See you guys. And if you could answer any of my questions in the comments, I'd really like that. Join the Discord.